28th lesson. If all has gone well, because I'm pre-recording these, but take a moment, answer the do know. And then you would normally talk to a neighbor and we come back and see what people think. So pause me now because I'm going to keep going. All right. For a relationship to be a function, each input can only have exactly one output. So I have a question. Can the amount of numbers in a function's domain be less than the amount in the amount of numbers in its range? Why and why not? Oop. I know that sometimes happens. We'll just do this again. Let's see if we can get it. It should come back on. There we go. Oops. Okay, so can you have less amount of numbers in here than in here? Why or why not? Right? Can you have two numbers here, like 2 and 6? And if we're going to say it's less, then we would have to have 3, 4, and 5. So can the amount of numbers in a function's domain, in this case, be less than the amount in this range? We're thinking why or why not? So this is a great example. If you have 2 here, 3 here, it has less. Can this still be a function? Okay, so why or why not? And I would say, I think the answer is no, right? You can't have less numbers in the domain because, well, what would you say? Why can't you? That's a great example. Because each domain has to go to a range, right? So if we have 2 domains and 3 ranges, that means 2 would go to 3, and 6 could go to 4. But that means one of these other domains has to go to 5. So this input has to have 2 outputs. So if there are less numbers in the domain than in the range, one input will have 2 outputs, and that is not a function. Cool. And that's what some people say. They figure out you gotta have at least the same, because if there were more, then an element or a number from the domain would have to go to 2 elements in the range. Just not possible. Not a function. Okay. So the next part is the PowerPoint. So hang in there for a second while I switch to the PowerPoint. Okay. So you're going to go open up to your notebook. I thought I gave myself a heading. That's weird. Maybe the heading's coming up later. No. Okay. Oh, it's here. Sorry. Okay. So first, inside your notebooks, time out for a second. Let's go here. Give yourself the heading 3.3 function notation. So 3.3 function notation. That's the first thing I'm going to talk about today. Okay. now I jump to our PowerPoint. So, did you know that many equations are actually also functions? For example, y equals 2x plus 10 is also probably a function. Well, why? Well, does each of its input values give back exactly one output? Right? The answer is yes, because y is a function of x. I want you to write that down. Y is a function of x. Well, remember we switch it to y depends on x, right? The y value in this case depends on what the x value is. So what if well, let's try it, right? If we have our inputs, do we get exactly one outputs? For example, if we put 1 in for x, what do we get for y? 12, right? And then if I put 5 in for x, what do you get for y? 20. Then I take 3 in and plug it in. 2 times 3 is 16, right? What if I take 1 again? Do I get 12 again? Yeah. What if I put 5 in? Do I get 20? Yeah. So whatever you put in, you're always going to get the same thing out in this function. So an equation is a function. Okay. So here's where we get into that equations can be written using something called function notation. So I'm going to write this down, function notation. So let's write this equation down, y equals 2x plus 10. And we're going to change it into function notation. Are you ready? Here you go, boom. Just did it. Now this equation is in function notation. Did you miss it? I'll show you again, ready? Y equals 2x plus 10, function notation. Boom, there it is. Equation, function notation. Equation, notation, function notation. Equation, notation, function notation. Equation, function. Equation, function. Equation, function notation. Equation, function notation. Function notation. Equation, function notation. Y equals, this equals. Y equals, that thing equals. Okay, so go ahead and write y equals 2x plus 10, and below it write this thing. Okay, and that's in function notation. The question is, what is that? Like, what does it mean, right? Okay, well, this f parentheses x is actually said as f of x. So, one time I'm going to repeat after me. F of x. Awesome. All right, say it again. F of x. Sweet. So this is pronounced f of x. And why do we say f of x? Well, we're going to talk about it right now. So this expression is said that f of x equals 2x plus 10. Okay, but to understand function notation, if you have this written, if you can add this f of x over here, each thing has a name. We are now calling this a function. So each little part of function notation has a name. For example, this f right here, or whatever comes right here in a function notation, that's just the name. The name of this function I gave was f. You can name a function with any letter you want. You might want to call it k, you might want to call it p or d, or you might even say, name of the function is Moran, or this function is awesome. Like, you can name your function whatever you want. And if you're a programmer, we do this a lot. We name our function stuff that does well. Like, we can talk more about that if you're interested. But for now, this little f is strictly the name. And our name of a function is always going to appear before the parentheses. Okay. So f of x, the f is the name. This in here, because it's a function and it's our x, that's what we say is our input. That's the input of the function, whatever you're going to input in here. Okay, this is sort of my own made-up thing, but this piece, which is equal to 2x plus 10, this is where you do the math. So this is the rule. This says take your input, whatever is x is, and you're going to do, well, what's the rule say here? 2 times whatever x is plus 10. That's the rule. Right, and this is going to be a little tricky, but when you have the name and the input like this, which is tricky for students, because it's in function, we've named the input, so we must have an output. The rule gives you the output, and so that's another way of saying that. Okay? So let's look at an example. So when we use function notation, we're going to be asked to find some answers. For example, we're going to ask to find the value of f of 5. And it's amazing that you can use these 5 symbols and it can ask you to do stuff. So find the value of f of 5. So what this is telling you is it wants you to find the function name f. Do we know where f is? Yes, it's up here. And what's the input for f? What input do they want to use? Well, the input's inside here, so they want you to input 5, right? So when f of 5 is saying when you input 5 into the rule, what do you get? So I'm going to do that. We're going to put 5 into the 2x plus 10, the rule, 2x plus 10. And then we just do the math. 2 times 5 is 10. 10 plus 10 is 20. So the 20 is our output. And you can't ask me questions, but we'll do another one. I think it'll make more sense. All right, let's take that same function named f with the same rule, and let's find f of 10. So find function named f and input 10 into the rule. So you do the math, and you should have got that f of 10 equals 30. You just take the input and do the math. Okay, so in class today, what we see is they do it slightly different. So I just wanted to give you an example like this. We're going to evaluate each function for the given input value. So can someone read this top part? So for f of x, it equals 5x plus 1. So what's the name of this function? Well, it's still f. Our input is x, but our rule has changed to 5x plus 1. All right, it tells you to find f of x, which is your output, when x is 2 and when x is 3. And normally I'd say, so what do you think this means, right? When it says find the output when x equals 2 and when x equals 3. Well, that just means you're going to do 2 problems. You're going to input 2 into function f, and you're going to input 3 into the function for f. Right? Take a function f and input 2 and 3 into the rule. So if you put in 2, you get out 11. And if you input 3, you get out 16. Any questions? You can do comments, you can message me. So we're going to see it look like this, and it's just a simple way of saying put 2 in for x, get an answer. Put 3 in for x, to the rule, get the answer. And this is just the notation to say you inputted 2, you get out 11. You input 3, you get out 16. Right? Okay, I'm going to jump back to the handout. So that was our first part of our notes. All right. So I'm going to talk a little bit more. We're going to jump to 3.4 while we're here. Why not, right? In 3.4, we're going to be talking about graphing functions. So take a moment. Write down the heading. And you don't have to write down the directions, but you can write down this and this. Okay, so we're going to be asked to graph functions, okay? And this is the directions. It's going to say graph this function for the given domain. Okay, so here's our function. Negative x plus 2y equals 6. And then it gives us this domain. Well, how do we make a graph of a function? Well, when we graph stuff, how do we get it onto a graph? Well, we need points, right? In a domain, is domain the x values or the y values? Right, it's our x values. Okay, so to do this one, they tell us the x values to use, which is really nice. Let's make a little table. With x, we have -4, -2, 0, and 2. And we need, though we don't have everything we need our y values as well over here. And you may or may not have gotten this point, I don't know where you got to, but this is called a process column, and so I'm going to put the process over here, this equation. All right, so this will tell us, we plug in our x and we'll get out y. So we got -4 plus 2 times y equals 6. Do some math here, and I'll take it over here just to do it. -4 is +4 plus 2y equals 6. To solve it a little bit more, boom, boom, 2y equals 2, and then y equals 1. All right, so I found one point, -4, 1, that I can plot to see what this function looks like. All right, I'm going to do the next one. Put -2 into the function. -2 plus 2y equals 6. And I might have to do some work over here, so I'm going to pull it out so my work doesn't get crazy in the center. -2 is 2 plus 2y equals 6. Take away 2 from both sides. Get y is 2. All right, I got another point. All right, we'll do the next one. We're going to put 0 in, so we have -0 plus 2y equals 6. And this one maybe I can do in my head. -0 is 0, so it doesn't matter. So we're left with 2y equals 6, which is 3. And then I got the last one, -2 plus 2y equals 6. So this one I might have to do over here. -2 plus 2y equals 6, add 2. 2y equals 8, so y equals 4. Cool. All right, so we now have enough information that we can graph this function. We have 4 points. We have -4, 1, -2, 2, 0, 3, and 2, 4. Cool. All right, we got one more. I know it's been a lot of notes. I think it's just one more. Yeah, and then I'll tell you what we're up to for the rest of class. So take a moment, add this one to your notes, and we're going to be asked to graph a function like this. All right, to graph a function, we need some points. We need x and y's, right? Shoot, well, this function doesn't have y anywhere, so can we even graph it? Well, yes, because we said that f of x is the same as y, so I'm going to rewrite this in equation form of y equals 2x plus 1. All right, now we do have an x and a y, so we're kind of good. Oh, shoot, though. They didn't give us any domain or x values to use, so what do we do? Right, it's almost better. If they don't tell us, the book doesn't tell us, or I don't tell you, you get to choose some x values, whatever you want to use. You can try 0 and 1 and 2 and 3. Sure, 4 is good. But we're going to plug them into our rule. And then we can get the y value that goes with each x. So if we do 0 squared times 2 plus 1, you get 1. And this one, 1 squared is 1. Right over here. 1 squared is 1. 2 times 1 plus 1 is 3. All right. So we get 2 times 2 squared plus 1. 2 times 4 plus 1, so we get 9. If we put 3 in, 3 squared, 9 times 2, 18, so we get 19. Awesome. Okay, so when I tell you to graph a function, you get to choose some points. 4 is good, 5, x values, choose whatever you want. And now we can graph this function by plotting points that we know. 0, 1, 1, 3, 2, 9, 3, 19. Okay, and I know you know how to plot points on a graph. I've seen that already. So we're not, when when I assign you the homework and classwork, I don't want you to create a graph of these functions. What I'd like you to do is make a table and get x and y pairs so we could graph it. Okay, so when I say graph, you need to make a table so we can graph. Okay, so your classwork tonight, give me 2 seconds here. No, let's keep that. I think it's a handout. Let me double check that. Yep, you get in a view of teachers. (183 to 184). 9 through 11. 20 through 22. Yep, so this is your classwork. Hold on, I'll show you. Guys, I'm teaching. This is a really bad moment to be doing this. Our classwork, 183, 184, you're going to be practicing this. And then you're going to go page 190 and do numbers 1 through 4. But for this one, you don't have to graph. No graphing. Just make a table and find points. Okay, so we'll go over the answers to that after tomorrow. But for now, there's your classwork, and I'll see you tomorrow.